Welcome to another Anatomy and Physiology Smart Art video, where we guide you through an important piece of art. After watching this video, you should be able to describe endochondral ossification, the process that replaces the early cartilaginous skeleton with bone. The key concept to grasp is that a hard ossified bone in the adult actually begins in the embryo as a miniature version made of hyaline cartilage. Let's take a closer look at the humerus of this embryo about 6 weeks after fertilization to see how the miniature cartilaginous model is progressively replaced with ossified bone. This process is not fully completed in all bones until after puberty. Some do not fully ossify until the late 20s or early 30s. Here you can see the cartilaginous model beginning the process of endochondral ossification. The chondrocytes in the center of the model become active, increase in size, which reduces the matrix to a series of small struts, and then die, leaving open spaces. Blood vessels invade this area, and osteoblasts at the periphery lay down a superficial layer of bone. Fibroblasts, delivered by the blood vessels in the central region, differentiate into osteoblasts and begin to produce spongy bone at what is called the primary ossification center. Over time, the primary ossification center undergoes remodeling that forms a medullary cavity. This process repeats at multiple secondary ossification centers located at the epiphyses. The epiphyses retain a thin layer of articular cartilage within the joint cavity. This layer will remain in the adult, and it covers the ends of your bones today. The epiphyseal plate separates the epiphyses from the diaphysis. This image here allows us to take a closer look at the epiphyseal cartilage to see how lengthwise growth of the bone occurs. Chondrocytes on the epiphyseal side of the plate continue to divide and enlarge, while those on the diaphyseal side die. Osteoblasts migrate to this region and lengthen the bone by laying down more bone. At puberty, various hormones cause the epiphyseal plate to be fully replaced with bone. This epiphyseal closure signals the end of skeletal growth. To summarize, endochondral ossification is a process in which we see the early hyaline cartilage skeleton replaced with hard ossified bone. It begins in the diaphysis at a primary ossification center and proceeds at multiple secondary ossification centers in the epiphyses. Hyaline cartilage remains at the epiphyseal plate to regulate lengthwise growth of the bone until skeletal maturity is reached and the plate ossifies. Articular cartilage remains in the joint cavity, covering the ends of long bones. So what? Why is it important to understand how bone grows? Well, the presence of an epiphyseal plate rather than an epiphyseal line tells us that a person's skeleton is still growing. An X-ray of mature bone that has stopped growing can reveal a distinct epiphyseal line. However, an X-ray of immature bone shows what appears to be open spaces because the cartilaginous epiphyseal plate is not visible in X-rays. Also, fractures at the epiphyseal plate are serious and require careful treatment because the damaged bone may stop growing at this site, risking asymmetrical limb length as the opposite limb continues to grow normally.